Hello and welcome everybody to today's webinar. I'm Kovacs, Chief Medical Officer of Argus Cognitive and also Assistant Professor at Semmelweis University and also a practicing cardiologist. First of all, let me highlight that you can have your questions in the chat box in YouTube. Therefore, if you have any questions concerning the presentation, then at the end of my talk I can review them and answer it. So feel free to ask if you have any questions concerning the presentation or the technology. So the topic of today's webinar is how to use ReVISION in your clinical or research practice. Actually, I would like to highlight not just a case report where the diagnostics provided by ReVISION was helpful, but also to show you how easy it is to use our software in relation with your Ecolabs infrastructure and how to get the ReVISION results using your existing infrastructure at your Ecolab. Let me briefly start with just a physiological overview of what we would like to talk about and what we would like to measure. So actually there are three main components of right ventricular pump function that can be separated. One is the shortening of the longitudinal axis with traction of the tricuspid annulus towards the apex. So this is the conventionally used and conventionally measured longitudinal function of the right ventricle as reflected by tricuspid annular plane systolic excursion, TEPSI, or even free wall longitudinal strain. However, there are two other important mechanical components, namely the inward movement of the RV free wall. That's what we call the radial motion, and you can appreciate here at the video, and we also call this the bellows effect. And there is a third one, the most neglected one, the anteroposterior shortening of the right ventricle, which is actually due to the contraction of the left ventricle by pulling the right ventricle free wall insertion lines towards each other. And actually this concept and these three mechanical components are highlighted in recent high-quality publications like this JACC scientific statement, lead authored by Professor Rebecca Hahn, where even in the introduction they highlighted that these three separate mechanisms that contribute to the pump function, and also with the discussion of the strengths and limitations of the different conventional echocardiographic measures like TAPSI or S' bar tissue Doppler imaging, they provided a note that it should be combined with other measures of RV function that also assess radial or anteroposterior or even circumferential and anteroposterior shortening. So this clearly highlights that these have important clinical consequences, and however we can assess these mechanical components only by three-dimensional echo and by our ReVISION software, which can actually quantify the relative contribution of these components head to head. A brief overview about our ReVISION software. There are three main feature sets how we approach a detailed characterization of right ventricular mechanics. So first of all, we need a three-dimensional echo-based right ventricular model, and we apply a so-called motion decomposition, meaning that we can separate the global motion into the three anatomically relevant orthogonal axes, namely the longitudinal, the radial, and the anteroposterior, and we can create three-dimensional models that are actually just shortening in that given direction, and we can calculate so-called component ejection fractions. So we can calculate longitudinal ejection fraction, radial ejection fraction, and anteroposterior ejection fraction, and that's how we can express the relative contribution of these three motion directions to the global function. We have also introduced volumetric segmentation using a 15 segment model. So just like as for the left ventricle, now we have the possibility to assess regional or segmental dysfunction using our software. And we also can calculate circumferential and longitudinal strains, but in a three-dimensional manner, meaning that this should be superior, for example, to those approaches where only a two-dimensional apical four-chamber view is used to calculate longitudinal strain or free wall strain, as these contours are all over the three-dimensional surface of the RV and capture the entire morphology and mechanical pattern. So let's turn our attention to our case report for today. This is a 58 years old lady with a new onset shortness of breath, and she had recently immobilized due to a lower limb fracture. Actually, when I performed her conventional echo, I found good left and right ventricular function. TAPC was normal, and I saw no right ventricular dilation by the conventional two-dimensional measurement. I also saw no wall motion abnormalities using the apical four-chamber view, and the pulmonary systolic pressure was within normal ranges. Using a three-dimensional echo, I saw a dilated right ventricle but a maintained global function of 46% of ejection fraction. However, if I show you the apical four-chamber view of this patient, and despite all these quantified parameters which were all normal, let's say, those who have sharp eyes can see that there are still signs for pressure overload in this ventricle. However, conventional parameters clearly failed to detect these abnormalities. So let's turn our attention to how you can use our online surface and how you can have quantified results using three-dimensional echo. So ReVISION is a software as a service currently undergoing FDA review and approval, and you can approach the software through logging in to our website. First of all, you have to register an account by typing in some data, and once you've done with this, you will receive an email from Argus Cognitive where aiming to confirm your email address. By clicking in the link provided in the email, your registration will be completed, and after that you can start using the system. So once you click on register, you will receive the email confirmation, and after that you can have a step forward. First of all, at our dashboard you should create a project. Currently we have two pricing plans. You can decide which one to use according to your needs, whether you want to analyze a lot of data or fewer data, whether you have raw 3D DICOMs or you have access to the Thumbtack system and therefore you will rather use the reconstructed RV models for your quantification. And once you provide all the details needed, you can sign up for a plan. Importantly, we have a 7 days trial period, meaning that you can use ReVISION for free and you can cancel your subscription anytime. And all these quantifications, both the UCD file based quantification and both the raw DICOM based quantification, is available to you in this 7 days trial period. So once you click create project, then you will be redirected to the Stripe surface where you can start your free trial period. Once you are click here to go to your project, you can see the status and the name of your project. You can modify anything. You can also invite collaborators to this project, and then if you go for the evaluation site, you can add evaluations based on 2 different types of data, namely the for the TomTec data or raw 4-dimensional ultrasound DICOM data. And in the upcoming slides, I would like to show you how you can get this data which is needed for the ReVISION analysis. Let's start with the raw DICOM data. So how to export it using commercially available systems. Let's start with GE's EchoPack. So once you have your patient identified, you identify that 3-dimensional data set that will be feasible for further analysis, and by a right click you can see this save as window, and both the raw DICOM and both the regular DICOM formats will be feasible for further analysis, and what exported here, that file should be then imported into our ReVISION software. Next one is the Philips TomTec ultrasound workspace. So how to export the DICOMs. So once you highlighted your patient, click export, and you should use the DICOM dir format. And if you want to identify the exact file you want to upload, right click on the patient study info, and you can check the images with this surface to identify the name of the given DICOM that should be later uploaded. And now you have your raw DICOM file. Next step is to upload it to our servers. So first of all, you need a unique evaluation ID, a short description for your reference. For further showing the reference values, you should signify whether this is a male or a female patient. And once you click on for the DICOM upload and you select your file, you should start the upload process. And once it is completed, you can start the evaluation. Importantly, you will receive an email notification once this evaluation is done. In this case, the state will change to intervention required. That means that in that case, this 3-dimensional DICOM will be processed by the Argus readers and will reconstruct the 3-dimensional model in-house. That means that we need about 3 working days to have this analysis performed, and once we are done with that, you will get an email notification that the results are ready for your review. The other type of inputs are the direct inputs from the TomTec for the RV function software in a UCD format. This UCD format actually contains 3-dimensional models of the RV in every time instant that has been analyzed and how you can export these UCD files. I will show you now. You should click on the so-called at the end of this analysis in the for the RV function. You should click on the export vital button. Once you identified the folder to these files to be placed, you should save them, and you can also double check that you can see several UCD files, but also with an accompanying TXT file called header, which is also needed for the analysis. Once you have your UCD files, then the next step is how to upload to the revision analysis. So once again, by creating a new evaluation and adding a unique ID, you should click on the for the TomTech data. You can browse your files in the middle box. You start the upload process, and once all of the UCD files plus the header TXT file is uploaded, you can start the evaluation. The state here says queued. That means that it is currently being processed, and once the state changes to succeeded, your results are available for your review. You click on the name of that case, and after that the revision software will load, and at the next slide I will show you the report page as the result of the analysis. Actually, this is the point then we turning back to our case. So the lady with shortness of breath, lower limb fracture, derived immobilization, and clinical suspicion of pulmonary embolism. On the revision report page, you can see the three-dimensional moving model. You can appreciate some paradoxical septal motion. Also on the bullseye map, there are decreased values, especially on the anterior basal free wall surface, and we can also see the, let's say, conventional 3D measures like volumes and ejection fractions. We can see that the ejection fraction is in low normal range. However, the systolic and diastolic volumes are increased. However, strain values are all normal. In this radar chart, you can see, however, that the radial shortening reflected by radial ejection fraction is significantly decreased, and meaning that this is much lower than the normal values. And you can also see a change in the contraction pattern, namely that this radial ejection fraction and the loss in the radial shortening is compensated by an increase in the anterior-posterior direction. So actually not just the values of these component ejection fractions, but also the relative ratio of them, which is visualized in this radar chart, can be suggestive for different pathologies. So in conclusion, using revision, in this case a severely reduced radial function can be appreciated with a radial ejection fraction of 5%. And there were also prominent regional wall motion abnormalities on the RV free wall basal anterior segments that can be a manifestation of the McConnell's sign, that are together characteristic signs of right ventricular pressure overload. What you can see in these three-dimensional models, that the longitudinal shortening was maintained in this case, as reflected by the orange model, which shortens only in the radial and only in the longitudinal direction. However, And actually this maintained longitudinal shortening was reflected by, for example, the normal values of TAPSE. However, there is a dramatic decrease in the radial shortening of this right ventricle, which is actually again characteristic to the RV pressure overload. And going back to our case, a subsequent CT angiography also confirmed the massive pulmonary embolism. Thank you very much for your kind attention. Please feel free to get back to us in any channels. And now I will check whether we have some questions in the chat box in YouTube. If you have any questions, feel free to ask. If no, I would like to thank you for your kind attention, and again, feel free to get back to us in any of the channels and share us your views and also feedbacks about our revision software. Thank you very much for your kind attention.